All right, so the last day of notes for this unit, we're going to look at all 6 trig functions again. And we're going to first determine what quadrant is theta in. So we need to kind of review what we've already discussed with the signs of the trig functions. So I'm going to show you guys the same thing, but kind of in a different way. You don't have to do it this way if you want, but I think it kind of makes a nice visual. So if sine of theta is less than 0 and tangent of theta is greater than 0, what does that mean? So sine of theta is less than 0, that would mean that sine is negative, and tangent of theta greater than 0 would mean that's positive. So let's look at our little sine chart over here where all students take calculus. So where is sine negative? Sine would be negative in quadrants 3 and 4 because everything's positive in quadrant 1 and sine is positive in quadrant 2. So tan is positive in what quadrants? Well, it's positive, everything's positive in quadrant 1 and it's also positive in quadrant 3. So where is both of these things true at? It's in quadrant 3. So that's where our theta lies. Another way we can think about this is by shading. Okay, so I have this little illustration shading this stuff so we can kind of see where things double overlap. So this is where this is where sine would be negative in quadrant 3 and 4. This is where tangent would be positive. Notice they overlap in quadrant 3. All right, this one, cosine of theta is negative, cosecant is positive. So that's, remember, cosecant and sine, that's the reciprocal for sine. So that's all we really need to kind of concern ourselves with. Cosecant is sine, or the reciprocal of sine. So where's cosine negative? Cosine is negative in quadrants 2 and 3, because all are positive in quadrant 1, and cosine is positive in quadrant 4. Oh, we're looking at negative, sorry, yeah. So negative 2 and 3. Sine, or cosecant, is going to be positive in quadrants 1 and 2. So it's going to be 1 and 2. So where those things overlap would be quadrant 2. We can shade it kind of like that last one. Cosine's negative in these 2 quadrants. Sine is positive, or cosecant is positive in these 2 quadrants, so they overlap in quadrant 2. All right, so find the value of the 6 trig functions of theta given the following information. Tangent of theta equals 4 over 3. The terminal side of theta is in quadrant 3. So this is not talking about the unit circle. This is just talking about, like, our radius does not have to be 1 here. So I'm going to go ahead and sketch out a right triangle in quadrant 3. And when we think about SOHCAHTOA, tangent is opposite over adjacent. So with respect to this angle theta, I'm going to go ahead and label my opposite side to adjacent side based off of my ratio that I'm given, 4 over 3, like this, opposite over adjacent. And now I want to find all other trig functions. So to do that, I need to find the hypotenuse as well. Using Pythagorean theorem, I see that my hypotenuse is equal to 5. Now that I know that, I can write the remaining 5 trig functions. So sine and cosine, that would just be y over h and x over h. So once again, this is not just y and not just x because I'm not dealing with the unit circle here. Because I don't have like you should be able to tell when you see like square root of 2 over 2, square root of 3 over 2, like one of those ones that we see pop up with the unit circle. This is not. So our sine and cosine, we have to remember that they are both negative in quadrant 3. Our cotangent, we're going to take the reciprocal of the tangent, so 3 over 4, that should be negative 5 over 4 and negative 5 over 3. Here we have the secant of theta is equal to 6 over 5. So the cosecant of theta would be 5 over 6. But we also want this where the sine of theta is negative. So let's go ahead and first, that's negative. That's in quadrant 3 and 4. So those are the 2 possible quadrants I can exist in. Let's go ahead and sketch this out. Oh, and by the way, secant of theta, which is the reciprocal to cosine, this is a positive number, right? It's given to us as a positive number, which means that they both have to be positive or both have to be negative because that's given to us as a positive number. So cosine is positive in quadrants 4 and 1. So those both overlap in quadrant 4. So this should be in quadrant 4. Now the secant is 6 over 5, so the cosine is 5 over 6. I'm going to go ahead and label these. Now cosine is adjacent over hypotenuse, so I label this 5 over 6. 5 there, 6 there. I can label, I don't know if I have my ordered pair or not, but I'm going to find, I'm not finding the hypotenuse, I'm finding the opposite side now, which should just be the square root of 11. Now that I have these, I can write all of my ratios out. And I always like to write my ordered pairs, that way whenever I write my x or my y, it helps remind me what is negative here. So we had the cosine of 5 over 6, secant of 6 over 5. The cosecant and the sine, I'm going to write my sine and tangent first. So the sine is opposite. So opposite is square root of 11. But notice square root of 11 is negative because that's the y value over the hypotenuse of 6. So that's negative square root of 11 over 6. The cotangent is 5 over negative square root of 11. Tangent's negative square root of 11 over 5. And that's all there is to this unit. That's what you have to know. Now it's a matter of completing and getting the necessary practice to be successful on this test. So you have a practice worksheet 8.4. Once again, as always, make sure you're asking questions as you have them.